Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 28, 2025, just 2 days ago. This paper serves as a comprehensive, graduate-level introduction to the group algebras of symmetric groups, aiming for accessibility. The paper is titled, An Introduction to the Symmetric Group Algebra, and it's a fantastic resource that integrates foundational concepts with modern results. It systematically introduces several families of algebraic elements, and then delves deep into their structure and representations. And it's definitely getting attention. People on X are highlighting its impressive scope, noting it's a massive 830 pages, and even includes a practical Sage Math tutorial. And this table of contents really shows that methodical approach. After laying out the prerequisites, it dives right into the introduction to symmetric group algebras, which are essentially mathematical frameworks for studying all the possible ways to shuffle a set of objects. A major focus is on what are called the Young Jucys Murphy elements, or YJM elements. These are special components within the algebra that have a really useful property. They commute, which simplifies a lot of the math, and they lead to key results like the transposition cancellation theorem. Building on those foundational elements, this next part of the table shows the shift into the core of the paper, representation theory. This is where the authors represent the abstract shuffling operations as more concrete mathematical objects, like matrices. They introduce what are called modules, which are structures that the algebra can act on. The real goal here, as you can see in section 5, is to build what are known as Young and spec modules. These are constructed using combinatorial grids called Young tableau, and they are incredibly important because they give you the fundamental building blocks, the irreducible representations of the symmetric group. This then leads into section 6, which is all about the different bases of the symmetric group algebra, KSN. Now, a basis is essentially a set of fundamental building blocks. Think of them like primary colors that you can mix to create any other element in the entire algebraic structure. The authors cover several, like the standard basis and the Young symmetrizer basis. But the real highlight here, as you can see in section 6.8, is the detailed treatment of the Murphy bases. These are built directly from those commutative Young Jucys Murphy elements we talked about earlier, showing how everything connects. And this proof here really gets to the heart of how those Young Jucys Murphy elements work. What we're seeing is a key step, a recursive relationship. It shows that the symmetrizer for k elements, which is just the sum of all possible shuffles of those k items, can be built from the symmetrizer for k minus 1 elements simply by multiplying it with 1 plus the kth Young Jucys Murphy element. This is so important because it provides a direct constructive link between these two fundamental algebraic objects, paving the way to factor the full symmetrizer. So in conclusion, this is a remarkably thorough guide. The key takeaway is how central the Young Jucys Murphy elements are to the structure of symmetric group algebras, connecting foundational concepts directly to the construction of advanced bases and representations. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.